Hi, this is the 2018 Question 6 Part A, Part 1. It's a queuing theory question. So it says let Px of t equal n be written as Pn of t be the probability that there are n customers in the system at time t, with An delta t and Dn delta t being the probabilities that there is an arrival and a departure in a small interval time delta t respectively. So then you have to mathematically justify the equations. P0 of t plus delta t equals 1 minus A0 delta t minus D0 delta t P0 of t plus D1 delta t P1 of t plus little o delta t and Pn t plus delta t. We'll get into that later. Okay, so the notation is Pn of t is the probability that there will be n customers in the system at time t. P0 t plus delta t is the probability that there's no one, that's what the zero is for, in the queuing system at time t plus delta t. An delta t is the probability that when there are n people in the queue, there is one arrival, in the little extra time interval delta t. So if there were n people, that would now bring it up to n plus 1 people in the system, provided no one departs. Okay, and then dn delta t is when there are n people in the system, there is one departure in the small a time interval delta t. It is the probability that when there are n people in the system, there is one departure in the small time interval delta t, which means there's going to be one less people in the system now, unless somebody else arrives. And then if you look at the probability, D0 delta t P0 of t. P0 of t means there's nobody in the queuing system at time t. And then D0 means there is one departure when there's zero in the queue. That can't happen. There's a zero because there cannot be a departure if there's no one in the system. Okay, so here's an explanation of it, right? There's a long equation we were given at the beginning of the question, and we want to know the probability of 8 people being in the system at time 20 plus 0201 minutes. So this is just an explanation. This isn't really part of the answer. So we're going to say let n equal 8 because we want n people to be in the system. So it's a probability of n being 8 people being in the system. Let t equal 20. Let delta t equal 0.01 minutes. And then that means t plus delta t is 20.01 minutes. So here it is. The probability that there are 8 people in the queuing system at time 20.01 minutes is the probability that there are 8 people in the queuing system at time 20 minutes and that there are no arrivals or departures. The probability that there are 8 people in the system at time 20 minutes, that's this part, P8 of 20, and the probability that no one arrives or departs in the small extra time of 0.01 minutes. That's this part here. So there is still just 8 people in the system. Now this one here is the probability that there are 7 people in the system at time 20 minutes. So we need an arrival to bring it up to 8 people. So that's the arrival when there are 7 people in the queue, and that arrival occurs in the little extra time interval 0, 1 seconds, minutes. The probability there are 7 people in the system and the probability that one person arrives in the extra time interval 0.01 minutes. So there are now 8 people in the system at 0.01 minutes. Or the next situation, that there are 9 people in the system at time 20 minutes and we have a departure in the little extra time interval. So the probability there are 9 people in the system and the probability that one person departs in the small extra time interval 0.01 minutes. So there are 8 people in the system at time 20.01 minutes. And then the last one, little o. This is the rare probability that more than one person arrives or departs in the small extra time interval 0.01 minutes. And little o is a function that's of order 0.01, which makes it smaller. So it could be 0.01 squared, which would make it much, much smaller. So you can see from above there are one term, two terms, three terms, four terms because they're all split by the plus sign. Four terms means there are four situations, and I've explained each of the four situations here. Okay, and overall there will still be 8 people in the queuing system at time 20.01 minutes. Either there's 8 people there at 20 minutes and nobody arrives or departs. There are 7 people at 20 minutes and there's one arrival. There are 9 people at 20 minutes and there's one departure, or something very rare happens. That's going to have a very low probability that more than one person arrives or departs. Okay, so now let's get back to the question. Right, so we have to mathematically justify this equation that the probability that there are no people in the system at time t plus delta t is equal to these three situations. Situation 1, situation 2, or situation 3. So when there's a plus in probability, it is or. And when there's an and in probability, you multiply. And we have multiplication here. So P0t plus delta t is the probability there's no one in the queuing system at time delta t. And there are three situations where this can occur. 1. The probability there's no one in the queuing system at time t, and the probability there are no arrivals or departures. So the probability there's nobody in the queuing system at time t is P0t, and is multiply because they're probabilities, and then there are no arrivals or departures is 1 minus the probability of an arrival minus the probability of a departure. And we multiply those and we get this. Okay, and then the second situation, or, which is plus mathematically, the probability there is one person in the system at time t, P1 of t, and the probability that one person departs. That's a multiply, the probability that that one person departs. So we have one person in the system and they depart in the little extra time interval. And that's this term here, which is written there. And then or, which is okay then. The next part, that's Pn of t, that we have n people in the queuing system at time t plus delta t. You can see from this there are four terms here in this question, so we're going to have four possible situations. There are four possible situations that this can occur. The first one is this one here, right? The probability there are n people in the system at time t, which is Pn of t, and, which is multiply, we have the number we want, so we want no arrivals or departures. The probability of no arrivals or departures is 1 minus the probability of arrival or departure in the small time interval. That's that part. Now the second term, this is or for the second situation, the probability there are n minus 1 people in the system at time t, which is represented by Pn minus 1 of t, and, so that means we're going to multiply the probability that one person arrives. So when there's n minus 1 people in the queue, one person arrives in the small time interval delta t. That's that one. That's the second term. Then plus or the third term, the third situation, the probability there are n plus 1 people in the system at time t. So that's one person more than the probability we're hoping for. Right, n plus 1 people in the system at time t, and we multiply the probability that one person departs in that tiny time interval, that's d, n plus 1 delta t. So there are n plus 1 people in the system and one departs in the small time interval delta t. And that's that, the third term. Or the last situation, the probability that more than one person arrives or departs in the small time interval t to t plus delta t, and that's little o delta t. That's it. Thank you.